This is Mrs. O'Neill for AP Chemistry, Chapter 2, Section 3, the modern view of atomic structure. I want to remind you how we talked about how the atom has changed its view or structure according to the different experiments that scientists have discovered and the models that have been used over the years. So this is the modern view. I'm getting more detailed as to what the modern view of the atomic structure is. So your objective is to explore this modern atomic structure of the atom, but more specifically, now we're going to get into what the atomic number, mass number, and isotopes are. So again, I want to remind you, you may want to pause the video, fill in the blanks in your packet, and then play to hear my words. So just as a reminder, the electron, proton, neutrons, and what their charges are. An atomic mass unit really represents how much grams the mass of an electron or atom is. This is not a big deal, but it is when we talked about that Coulomb's unit and the charge to mass ratio. You also want to remember angstrom. Sometimes they do bring this to our attention in our books. I don't think it's on the reference sheet, but it used to be. So it is the non-SI unit for the length of an atom. And we want to notice that the 1 angstrom is really 1 times 10 to the negative 10 meters. So we want to think of electrons and protons as this. Electrons are to protons as fleas are to an elephant. Yes, the electrons are that small and have that much less mass than a proton. So I like to give you these analogies, especially visually, to get you to understand how small and very, very small mass. Okay, so besides the tininess of it, the mass of it is so tiny compared to that of a proton or a flea to an elephant. So just as a reminder, the difference between atomic number, mass number, and isotopes. Atomic number gives us the number of protons, which in a neutral atom also equals the number of electrons, but that's only in a neutral atom. So hopefully you remember during Chem 1 that the electrons can change and then there's a charge on the ion. So we want to remember that the atomic number or the number of protons really is going to identify an element from one another. We want to remember that the mass number is the protons and the neutrons added up together. And we want to remember that isotopes are atoms with the same number, again, protons, but they will have a different mass number because their number of neutrons change. So with all this information, hopefully you understand that the protons of an element will never ever change. Just like number of protons in an atom is sort of like characteristic that distinguishes a human as a male. So if we look at a person and has certain characteristics, then that person is a male. So if an atom has a certain number of protons, it's going to decide that that particular element is what it is. So for instance, the number of protons will determine the element. So if we look at carbon here, no matter what, if I discover an element, or if I do some research and in my research I have an atom that has 6 protons, no matter what, I will know that it is the carbon atom. So the protons are going to determine an element, just like certain properties or certain characteristics describe a human as a male or a female. So symbols, sometimes you will see the element written like this. We always want to remember it's the A or the mass number on top, or the Z, the atomic number, on the bottom. And again, don't drive yourself crazy. We want to remember that the mass number is always going to be your biggest number. So the mass number will always be larger than the atomic number. So you don't really need to memorize what order that is. So this is it for this section. Nice, quick, and short.